All right, today we're going to be in Unit 2, that's called Linear Functions and Inequalities, and we're going to be on page 29, and today is the last notes page for this unit, and it's our last page talking about inequalities. So today we're going to talk about compound inequalities, and this is when two inequalities or more are joined together with the word and or the word or. All right, so it says or inequalities have a tendency to be graphed apart. So the front of this page, we're only looking at or inequalities, and then on the back, so on page 30, we're going to be looking at and inequalities. So the example right here says that x is less than or equal to 2 or x is greater than 3. So we're just going to look at these separately, but graph them on the same number line. So the first one, x is less than or equal to negative 2. So since it's less than or equal to, I'm going to put a closed circle on negative 2, and I'm going to shade to the left. All right, then the next part says x is greater than 3. So I'm going to put an open circle on 3 because it's greater than, and then I'm going to shade to the right. All right, so that's how you graph an or inequality. It's going to be one number line with two graphs on it. Now we're still going to be doing interval notation, so just like we've been doing before, if your arrow is pointing to the left, that means it goes to negative infinity. If it's pointing to the right, that means it's going to positive infinity. So this first one right here, okay, it's pointing to negative infinity, so it's going to be parentheses, negative infinity, comma, negative 2 with a bracket because it's a closed circle. All right, and the second one is pointing to the right, which means it's going to it's going to positive infinity. So since it's a open circle on 3, I'm going to use a parentheses, comma, positive infinity with another parentheses. Now, in between these two inequalities, you're going to write the word or. And then that's how you would do the interval notation. All right, so let's look at some more examples. All right, so first we're going to have to solve the inequalities, which we've been doing this whole unit where we're talking about inequalities. So to solve for x in this first one right here, I need to get x by itself. So to do that, I have to move that negative 4 to the other side. So I'm going to do the opposite, and I'm going to add 4 to both sides. So those cancel, so I'm left with x is less than negative 7 plus 4, which is negative 3. So that's the first one. I'm going to bring down or. And then the second one, I have 2x is greater than or equal to 12. So to solve for that, I got to get x by itself. So I need to move that 2 to the other side. So I'm going to divide both sides by 2. So x is greater than or equal to 6. So here's the inequalities that I need to graph. So let's look over at our number line. So x is less than 3 is the x is less than negative 3 is the first part. So I'm going to put an open circle on negative 3. And since it's less than, I'm going to shade to the left. And then the second part, x is greater than or equal to 6. So that's a closed circle. And since it's greater than, I'm going to shade to the right. Now remember, if your graph is pointing to the left, that's negative infinity. And if it's pointing to the right, that's positive infinity. So for my interval notation, I'm going to start with the one that's pointing to negative infinity. So that's going to go parentheses, negative infinity, comma, negative 3. And since it has an open circle, that's a parentheses. Then the word or. Then the second part is pointing to the right, so that's that's positive infinity. So I'm going to have a bracket with 6 because it's a closed circle with positive infinity and a parentheses. All right, let's look at number 2. So we have negative 3x is less than or equal to negative 9, or x plus 5 plus x is less than 6. So the first thing I need to do is solve these two equations. So the first one, I have to get x by itself, so I need to move that negative 3 to the other side. So I'm going to divide by negative 3. All right, and remember, when you divide by a negative number, okay, our inequality sign is going to flip. So those cancel, so I'm left with x is greater than or equal to, because it flips, positive 3, because negative 9 divided by negative 3 is positive 3. All right, then I'm going to bring down or. And then the second one, I have to get x by itself, so I need to move that positive 5 to the other side. So I'm going to subtract 5 from both sides, which leaves me with x is less than 1. All right, so let's graph these on our number line. Our first one, x is greater than or equal to 3. So I'm going to put in closed circle on 3 and shade to the right. Then my second one, x is less than 1. So I'm going to put an open circle on 1 and shade to the left. Okay, if your graph is pointing to the left, that's negative infinity. If it's pointing to the right, that's positive infinity. So when I write my interval notation, I want to start with the one that's pointing to the left. So I'm going to have parentheses, negative infinity, comma 1 parentheses, because it's an open circle on 1. Then for the one that's pointing to the right, I'm going to have a bracket, 3, because it's a closed circle on 3, comma, positive infinity with a parentheses. All right, number 3. 2x plus 9 is greater than 17, or 5x plus 10 is less than 10. So the first thing I need to do is solve these equations. So looking at the first one, I need to get that 2x by itself, so I need to move that positive 9 to the other side. So I'm going to subtract 9 from both sides. And I'm left with 2x is greater than 17 minus 9, which is 8. And then I still have 2 sitting next to x, so I need to get rid of that. So I'm going to divide both sides by 2. So x is greater than 4. All right, then for the next one, I need to get 5x by itself, so I'm going to subtract 10 from both sides, which leaves me with 5x is less than 0. Then I still have that 5 sitting next to x that I need to get rid of, so I'm going to divide both sides by 5. So x is less than 0. So now we're going to graph these on the number line. So my first one, x is greater than 4, so I'm going to have an open circle on 4, and since it's greater than, I'm going to shade to the right. And then x is less than 0, so I'm going to have an open circle on 0 and shade to the left. Now remember, if it's pointing to the left, it's negative infinity. If it's pointing to the right, it's positive infinity. So when I write my interval notation, I'm going to start with the one that's pointing to the left. So it's going to go parentheses, negative infinity, comma 0 with parentheses because 0 has an open circle. Then for my second one, I'm going to have parentheses 4 because it's an open circle, it's parentheses, comma, positive infinity. All right, number 4. we have 7x minus 14 is greater than or equal to 0, or 4x plus 5 is less than or equal to negative 3. So the first thing I have to do is solve these equations. So looking at the first one, I need to get 7x by itself. So in order to do that, I need to move the negative 14 to the other side. So I'm going to add 14 to both sides. So that leaves me with 7x is greater than or equal to 14. And then I still need to get rid of that 7 that's sitting beside x. So I'm going to divide both sides by 7. So x is greater than or equal to 2. Because 14 divided by 7 is 2. All right, for the next one, I have 4x plus 5 is less than or equal to negative 3. So I need to get that 4x by itself. So I'm going to subtract 5 from both sides since it's positive. And negative 3 minus 5 is negative 8. And then lastly, to get x by itself, I need to divide both sides by 4. So x is less than or equal to negative 2. All right, so now we're going to graph these. So the first one, x is greater than or equal to 2. So that's a closed circle on 2. And since it's greater than, I'm going to shade to the right. And then x is less than or equal to negative 2. So that's a closed circle on negative 2, shaded to the left. Okay, remember, if your graph points to the left, that's negative infinity. And if it points to the right, that's positive infinity. So for interval notation, you always start with the one that's pointing to the left. So that's going to be parentheses, negative infinity, comma, negative 2 with a bracket because it's a closed circle. And then bracket positive 2 because it's also a closed circle, comma, positive infinity with a parentheses. All right. Number 5, this time we have some parentheses that we're going to have to get rid of. So we're going to solve these two equations. So the first one, I got to get rid of the parentheses. So I'm going to take that negative 3 and distribute it to the two things inside the parentheses, and that is using multiplication. So I have negative 3 times 2x, which is negative 6x, and negative 3 times positive 1, which is negative 3. All right, now I'm still trying to solve for x, so I need to get negative 6x by itself. So I'm going to add 3 to both sides. So I'm left with negative 6x is less than negative 12. Then I need to get rid of that negative 6. So I'm going to divide both sides by negative 6. And since I am dividing by a negative, my inequality sign is going to flip, so I'm left with x is greater than positive 2. All right, for the second one, I have 1 minus x is greater than or equal to 5. So I need to get that minus x by itself. So to move that 1, I'm going to subtract it from both sides. All right, then that negative sign sitting next to x represents a negative 1. So I need to move that to the other side as well. So I'm going to divide both sides by a negative 1. We are dividing by a negative number. So my inequality sign is going to flip. So x is less than or equal to negative 4. All right, so now we're going to graph these. So looking at our number line, my first one is x is greater than 2. So that's an open circle on 2. And I'm going to shade to the right because it's greater than. My second one is x is less than or equal to negative 4. So that's a closed circle on -4, and it's shaded to the left because it's less than. Now remember, if it points to the left, that's pointing to negative infinity. If it's pointing to the right, that's pointing to positive infinity. So we always start with the one that's pointing with negative infinity. So I'm going to have parentheses, negative infinity, comma, -4 with a bracket, because that's a closed circle. And then for the second one, I'm going to have parentheses 2 because it's an open circle, positive infinity with a parentheses. All right, so that's all the examples on or inequalities. Now we're going to go to page 30, and we're going to talk about and inequalities. So and inequalities have a tendency to be graphed together. So they're actually going to be graphed on the same graph. So let's look at our example. So we have x is greater than or equal to -6. That's a closed circle on -6, and it's going to be shaded to the right because it's greater than. And then the second inequality is x is less than or equal to 1. So that's a closed circle on 1, and then it's less than or equal to, so it's shaded to the left. So if you look, in between -6 and 1, our graphs are overlapping. Okay, so where these two graphs are overlapping, that is our solution. So, because the solutions to an and inequality fall in between two endpoints, they are frequently written in a more condensed form. So, instead of writing our inequalities like this, which is the way that it showed us in that example, we're going to write our inequalities like this. Okay, and I didn't say this before, but looking back at the example, like I said, our solution is where they overlap. So -6 is a closed circle, so that's a bracket, and +1 is a closed circle, so that's a bracket. So that's what our interval notation would be. It would only be where those two inequalities overlap at. So that's why we write them like this. It's just a lot easier to write them like that. All right, so let's look at some examples. All right, so they're going to look a little bit different now, but we're still going to solve them the same way. So we have 2 is less than or equal to x plus 4 is less than 9. So just like when we solve a normal equation, what we do to one side, we have to do to the other side. Well, now we have two different other sides that we have to add or subtract or multiply or divide things to. Okay, but it's the same process as solving an equation. So we have x that we need to get by itself. So I need to move that +4. So to do that, I subtract 4. So I'm going to subtract 4 from 9, and I'm also going to come over and subtract 4 from 2. So these 4's cancel, so I'm just left with x in the middle. Okay, and then 9 minus 4 is 5, and 2 minus 4 is -2. So that is the solution that we're going to graph on the number line. All right. Sitting next to -2 is a less than or equal to sign. So that tells us that that is going to be a closed circle. And then there's a less than sign sitting next to the 5. So that tells us that's going to be an open circle. And then we're just going to connect those two dots together once we get them graphed. So looking at our graph, -2 is going to have a closed circle, and 5 is going to have an open circle, and then we shade in between. And that's how you graph an and inequality. So for interval notation, I'm going to have my two endpoints, which is -2 and 5. All right, 2 is going to have a bracket because it's closed, And 5 is going to have a parentheses because it's open. And that would be our interval notation. All right, let's do number 7. So we have negative 27 is less than 7x minus 13, which is less than 8. So just like any other equation, I need to get that 7x by itself. So to do that, I have to move the negative 13. So I'm going to add 13 to both sides. So my 13's in the middle cancel, so I'm just left with 7x. Negative 27 plus 13 is negative 14, and 8 plus 13 is 21. Now my last step is to get x by itself, so I have to move that 7, so I'm going to divide all sides by 7. So negative 14 divided by 7 is negative 2, and 21 divided by 7 is 3. All right, and this is the solution to our inequality. Negative 2 has just a less than sign, so that's an open circle. 3 has just a less than sign, so that's also an open circle. So we're going to graph those two circles, and then we're going to connect them together. So negative 2 is an open circle, positive 3 is an open circle, and then we shade in between those lines. So when I do my interval notation, I'm going to have my two numbers, negative 2 and 3, and they're both going to have parentheses because they're both open circles. So that's our interval notation. All right, number 8. So we got to solve it first. So I need to get 3x by itself. So to do that, I got to add 4 to all sides because it is negative. The 4's in the middle cancel. So negative 16 plus 4 is negative 12. And 2 plus 4 is 6. Now I still have to get rid of that 3 that's sitting next to x, so I'm going to divide all sides by 3. So negative 12 divided by 3 is negative 4. 6 divided by 3 is 2. So this is the answer to our inequality. Negative 4 has less than or equal to, so that means it's going to be closed. 2 has less than or equal to, so that means it's also going to be closed. So I'm going to draw those two circles on my number line and then connect the dots together. So negative 4 is a closed circle, and 2 is a closed circle, and then I connect them. So for my interval notation, I write my two endpoints down, and they're both going to have brackets around them because they are both closed circles. All right, number 9. So to solve this, I need to get that 2 over 3x by itself first. So I need to subtract 1 from all sides. My 1's in the middle cancel, so I'm left with 2 over 3x in the middle. Negative 1 minus 1 is negative 2, and 5 minus 1 is 4. Then my last step to get x by itself is divide everything by 2 over 3. So that leaves me with x in the middle. Negative 2 divided by 2 over 3 is negative 3. And 4 divided by 2 over 3 is 6. Okay, remember that's something that you can type in the calculator. So this is the solution to our inequality. 3 has just a less than sign beside it, so that's an open circle. 6 has less than or equal to, so that's a closed circle. So for our inequality, -3 is, what did I say? -3 is open, and 6 is closed, and then we connect them together. So for my interval notation, I'm going to have -3, 6. -3 is going to have a parentheses because it's open. 6 is going to have a bracket because it's closed. All right, let's do the last one, number 10. So we have -2 is less than 2 parentheses x minus 6, which is less than or equal to 4. So we have parentheses in the middle, so that's the first thing that we need to get rid of. So I'm going to distribute the 2 to both things inside the parentheses, and that's using multiplication. So 2 times x is 2x, 2 times -6 is -12. And then everything else gets brought down. Now I need to get 2x by itself, so to move that -12 to both sides, I'm going to add 12. So that leaves me with 2x in the middle. -2 plus 12 is 10, and 4 plus 12 is 16. And then my last step is to divide all sides by 2. So that leaves me with just x in the middle. 10 divided by 2 is 5. 16 divided by 2 is 8. So this is the inequality that we're going to graph. 5 has just a less than sign, so that's going to be open. X has less than or equal to, or 8 has less than or equal to, so that's going to be closed. So let's graph them. So 5 is going to have an open circle, 8 is going to have a closed circle, and then I connect the dots. So for my interval notation, I'm going to have 5, 8. 5 is going to have a parentheses, and 8 is going to have a bracket, because 5 has an open circle and 8 has a closed circle. All right, so that concludes our notes on compound inequalities.